Start. Okay, let's introduce the switch operation of the overall energy storage cabinet. First of all, this is the battery cluster. We divide it into 5 battery clusters. Then the 5 battery clusters each have 5 high voltage boxes. At this time, when we are in the first step, is to turn it on first, control cabinet, and then what? This is BMU's AC power supply. It is powered. It is the 220 low voltage power supply of the entire main control box. And here is the high voltage control switch. We can turn it on at this point after opening. It is already a state waiting to be turned on. Then what about the main control boxes at the back? In fact, it is the same as its operation method. It's all turned on now. One opening step of our battery compartment is completed. Then let's introduce. This is our main control box bus cabinet. It's an energy storage cabinet. All the low voltage lines and 220 AC lines inside. It's all on this. So first we have to turn this on. The entire energy storage. DC power will be supplied to that MPS. Okay, first of all, what about the steps to boot it up? There is a UPS power supply on it. We need to turn this UPS power on first. Then press this to turn on the UPS power supply. Then after turning it on, what we see at the bottom is a control switch. There is a BMS for dual switches. We can turn on the BMS, fire protection, if it works normally. Fire protection must also be turned on. And then there's this switching power supply and monitoring. Monitoring equipment can also be turned on. Then the spare socket and this spare. All of these systems that we control, it's all here. When it's opened, we can see that on this display of BAU, it will display some information about our battery. What about this time? We're going to send commands through the BAU to control those master boxes in our battery compartment for booting. Put the high pressure up on the bus cabinet of our energy storage battery. First, we have to log in. What about after logging in? We are going to connect to the grid. What about the grid connection at this time? Use one click to open the grid switch. Then start the grid connection to confirm. At this time, the BAU will initiate the command. Then let all the battery clusters suck in. And what about this process? You need to wait, because the battery cluster is based on box by box, judging one by one, after judging his voltage up. Then the next cluster will be powered on normally. That DC switch needs to be turned on. I'll put the high voltage on the system first. Then if the high voltage comes up at this time, we're going to put this DC switch on this battery. Because our battery clusters are all connected here, the whole power supply to the system passes through here. Then turn on. Let's turn this on first. After the DC switch of the battery is turned on, then the electricity is fed to the MPS. Then after opening, we have that UPS powered and air-conditioned one here. How about these? They are all connected to this AC MPS switch. When MPS is turned on, then we can turn this switch on. Then power and light these UPS. Include some commonly used fan functions. Then turn it on. You can see this. At this time, the voltage of the battery cluster has already risen. This signal light on our main control box is now green. The green light shows normal. Okay, now it's normal high voltage start. After starting, we're going to take a look. How do you need to operate on this MPS? We're feeding DC into our energy storage system. Now, the high voltage of our battery cluster. It has been uploaded to this MPS. Now there is already voltage on it. We can see this QDC. In the case of QDC, the direction pointed by the arrow is pointing to no. Then this time, the direct current of our battery, it has been supplied to MPS. What about after delivery? We can try something special. If you don't use the power grid, for example, it's nighttime for me, or when there is a mains power outage on the power grid, so we're going to simulate this environment. Just say this is the switch of the load. The switch of the load is connected externally. There are two-phase equipment and three-phase equipment, and AC power for our entire energy storage system. So we're going to turn it on. And after opening those, we are now simulating when the utility power goes on, and then we store it for self-inversion. What about after the inversion? We can see it on this display. It will display some information about our battery, including voltage. What is the current SOC? What is its state? Generally, we control it on the platform, its charge and discharge, and the converter. These switches, DC, AC switch. But what are we talking about now? Simple operations can also be performed on the display screen, like clicking on the menu. Let's log in first. We maintain that the password is 68S. What about after logging in? We can see it this time. We log in the energy storage system now. It's the AC converter that hasn't turned on yet. We can turn it on. For example, turn on the DC, AC converter. So let's turn it on now. Okay, what about after opening it? This time we can see, on this message, the battery is already discharging with the energy storage. Yes, this switch will suck in. And then this loading is sensed here. We are not turning on the power grid now. Switch on. So our loading now has voltage. What about after there is voltage? We're going to take a look at the entire energy storage system. Here it is. Let me highlight the main switch of energy storage system to control the entire AC power supply for the energy storage system. For example, a power supply from a UPS. It is powered by 220 volts. What about after the 4 air conditioners of 1234 above us are turned on? The air conditioner will work normally. This is lighting. It's in our entire container. All the lights. This light will be turned on here. Lighting on, and there's a switch. This switch controls all the legs. This light. Okay, now our air conditioner was just turned on. It has 4 air conditioners and can operate normally. And then there's an explosion-proof fan for power. The power supply from the explosion-proof fan is at the back. We installed 4 exhaust fans. Our exhaust fan will conduct that MPS heat on. Then other analog battery for inverter. The scene of discharging the battery to the loading. The simulation has been successful. Then the next step, check the utility. When the mains electricity is restored and reconnected to the power grid. So let's flip the switch. After opening, we can see on this display, it has the voltage of the grid. But what about the voltage of this grid? Just say to achieve charging. For example, when the power grid charges the battery, the system will deliver power. Let the grid discharge it. Because now we are executing a strategy. Now you look at the grid current. Already giving the energy storage cabinet and energy storage systems or loading for power supply. Then if we want to discharge, for example, the battery is put into the grid, we can deliver the power. directly let the three-phase inversion of the battery come out. It feeds into the grid. That's how it works. What about others? The entire energy storage system is now fully turned on. It can work and use normally.